Hello, Math 201 students. Going to go over the last 5 problems for the practice assessment. We already did the first 8, so let's get to it. So number 9, it gives us a function for the height of a projectile that's launched. And so here's the function for the height. And it wants to know the maximum height of the projectile. So if we could graph this function in our calculator, and if you get a reasonable window, then you could find the maximum height by finding the maximum in the calculator. But the calculus way to do this is to take the derivative of the position, and the derivative of the position s prime of t, that gives us the derivative of the position, gives us velocity. And when the velocity equals 0, when you get to that maximum height, that's when your velocity is 0 for an instant. So we get the velocity to be negative 32t plus 40, and we set that equal to 0, and at that moment we'll be at the maximum height. So move the 40 over, divide by negative 32, t will equal 5/4 when you reduce it, or 1.25 seconds. Now it actually asks if it said when is the projectile at a maximum height, we would be finished, but it doesn't say that. It said what is the maximum height. So to find that maximum height, I'm going to take that time and plug it back into the position function. So s of 5/4 or 1.25, just plug that into your calculator. Plus 40 times 5/4 plus 120. I might could do this by hand. That's going to be a 16, so that's going to cancel with that. That's going to be a 25, so negative 25. That's going to be a 10, so plus 50 plus 120. So that's going to be 25 plus 120. I believe the answer to that is going to be 145. So I think 145 feet would be the maximum height for that problem. All right, number 10, find the equation of the line that is tangent to the following function at x equals 2. So the equation of a line, y equals mx plus b, I just need to find the m and the b. Well, to find the m, I'm going to find the slope. The slope of the tangent line is going to be found by the derivative. The tangent line, the slope of the tangent line is always found by finding the derivative of that function. So the function itself, f of x, equals, I'm going to rewrite it as x squared minus x plus 7 to the 1/2, so that it will be easy to take the derivative. The derivative is 1/2 x squared minus x plus 7 to the negative 1/2. And then I have to do the chain rule, so that's going to be times 2x minus 1, right? That's what the derivative of the inside piece is. So cleaning that up a little bit, f prime of x equals 2x minus 1 is on top, a 2 is on the bottom, and the square root of x squared minus x plus 7 is on the bottom. Right, that the 2 is on the bottom, and the x squared minus x plus 7 to the 1/2 are square root. Because of the negative, it moves it to the bottom. And 2x minus 1 is on top. And I'm just plugging in what? I'm plugging in at x equals 2. I'm plugging in 2 for x. So f prime of 2 is 2 times 2 minus 1 over 2 times the square root of 4 minus 2 plus 7. It's going to be 3 over 4 minus 2 is 2. 2 plus 7 is 9. So square root of 9 is 3. 2 times 3 is 6. So 3 over 6, if I've done my arithmetic correctly, which is 1/2. So the slope is 1/2. So y equals 1/2 x plus b. Now, I believe what I will do is I will plug 2 into the original function to get an ordered pair for the point of tangency so that I can have an x coordinate and a y coordinate to plug into that tangent line equation. So if I plug in 2 to the function f of 2, that's going to be the square root of 2 squared minus 2 plus 7. That's 4 minus 2 plus 7. That's 2 plus 7. That's 9. That's the square root of 9, which is 3. So I have the ordered pair 2, 3. So I can plug in 2 for x and 3 for y. So 3 equals 1/2 times 2 plus b. So 3 equals, that cancels, it becomes 1 plus b. Subtract 1. So b equals 3 minus 1 is 2. So then finally the equation of the tangent line is just going to be y equals 1/2 x plus 2. That should be the answer to number 10. All right, the limit, we're evaluating the limit as x approaches 4. So if we just plug 4 in, let's see what happens. That's going to be 16 minus 4 minus 12 over 16 minus 16. Well, that's going to be 0 over 0, which is indeterminate, which means we got to do something else to figure out this limit. And so I think what would be the best thing to do is to see if the top and bottom factor, let's say that's going to be x minus 4, x plus 3 on the top, and x plus 4, x minus 4 on the bottom. The x minus 4 should cancel, and we come up with x plus 3 over x plus 4, which is the same function as the original function, except that it doesn't have that discontinuity or that hole in the graph at 4. So now we can just plug 4 into this. If we plug 4 into this, we get 7 over 8. So 7/8 should be the value of that limit. All right, number 12, what is the smallest possible perimeter for a rectangle whose area is 16 inches squared, and what are its dimensions? All right, number 12, smallest possible perimeter for a rectangle whose area is 16 inches. Okay, so we have this rectangle, and it has a length, it has a width, and we want the area to be 16. That means length times width equals 16. But we're trying to minimize the perimeter. So the perimeter is going to equal 2L plus 2W, right? And we want to minimize that, so we want to take a derivative of that or graph it and find the minimum. But I don't want to do it with two variables, L and W, so that's when I come up here and use this area equation to solve for one in terms of the other. So maybe I say W equals 16 over L, and I plug that in for W, so that P equals 2L plus 2 times 16 over L, which is 2L plus 32 over L. And then I could graph that, or I could take a derivative of it. I think I'm going to go ahead and get this as a, make it into one fraction. I don't know if that'll be easier or not, but I just kind of feel like it might make it easier. So I'm just going to try it. I'm going to multiply by this by L and L on top and bottom. That gives me 2L squared plus 32 over L. And now I'm going to take the derivative of that. And actually, when I take the derivative of that, I do think it actually would have been easier to leave it the other way to take the derivative. So let me back off of that. So the derivative is going to be 2 plus, and this is 32, L to the negative 1, so that's going to be actually minus. When I take the derivative, it's minus 32, L to the negative 2. which is going to be 2 minus 32 over L squared. Set that equal to 0. So 2 equals 32 over L squared. Cross multiply. 2L squared equals 32. L squared equals 16. L equals plus or minus 4. So now I have found L. Obviously it's going to be the positive 4, not the negative 4. Plug that back into here. If L is 4, then solve for W. 4W equals 16. Divide by 4. And W equals 4. So it's a 4 by 4 rectangle, aka a square. So the dimensions are 4 by 4, 4 length and 4 width, to make a rectangle whose area is 16 with the smallest possible perimeter. And finally, number 13, a rectangular vegetable patch with an, I think it's going to be similar to 12, with an area of 512 meters squared is to be enclosed by a fence and divided into 3 equal parts by extra fencing running parallel to one of the sides. So I've got this extra fencing. Dividing this thing into 3 equal parts. All right. It wouldn't have mattered. I could have drawn the extra fencing running this way. It would not have mattered. You could do it either way. So let's say this is L and L and L and L and W and W. Okay, so the area has to be 512. Area is 512, which is going to be length times width. And I'm trying to minimize the amount of fencing used. So the total fencing used is going to be 4L plus 2W equals the, let's say the fence. And so I'm going to use the area equation. So like W equals 512 over L to plug that in for W here. So 512 over L. So 4L plus 2 times 512 over L equals F. So F equals 4L plus 1024 over L, if I have done my arithmetic correctly. So now take the derivative, and that's going to be 4 minus 1024 over L squared, because this is 1024 L to the negative 1. So hopefully you can see how I got that derivative. Set that equal to 0. 1024 over L squared equals 4. So 4L squared equals 1024 divided by 4 means L squared equals 4 goes into 1,250 times, and then it's an extra 6 to go into the 24, so 256. So square root both sides, and the L will equal, I believe the square root of 256 is 16. So plus or minus 16. So obviously it's just going to be the positive one since we're dealing with length. So L is 16. L is 16. So then I got to do 512 divided by that. Do my calculator here. I get 32. So that means W equals 32. So this is a 16 by 32 rectangular fence. And it says, what is the minimum total length of fencing needed? So that actually doesn't answer the question yet. So the width was 32. So the total length, the total amount of fence needed is going to be 4 times 16, because that was the length, plus 2 times 32, because that was the width. And so 4 times 16, that's 64, plus 2 times 32, that's also 64. So the total amount of fencing needed is 128. That should be the answer. All right, I hope this does you some good for preparing for your standardized assessment. I hope you do well on it. Good luck, and I'll see you next time.